Can you guys hear me? Perfect. All right. So hopefully, oh, here's the one. Going in. So let me share my screen and explain what I'm going to do with you today. All right, so yesterday we went over this yesterday, I think, didn't we? Yeah. And I want to just recap it really quickly for you, just to make sure that you have it in your mind and you have it down, and then I want to explain what we're going to do with it today. So this is where if F is increasing. So if we have increasing here, then this is positive, and we don't get anything from that one. This is decreasing, then F prime is negative. We'll fill in the orange ones when we start to talk about concavity, whether a graph is concave up or concave down. That's sort of the next level. But we can also put increasing and positive here, and decreasing and negative here. And really what you're looking at is X values where this is occurring, okay? So you're looking at when does this kind of transition make, when is this made, really kind of honing in on the X values on when it works out. You get here, we have a relative max on F. Here, going from this one to this one is a relative minimum on F, and then this one is a relative maximum on F prime, and this would be a relative minimum on F prime. And really looking at those at those X values where this transition is occurring. I call it the chart. We'll finish it off, and we'll kind of get some new information on it in the next couple of days. Remember that a critical number is when the derivative is equal to 0 or undefined. Now, most of the time, if you have an equation, that's when we would be talking about the critical number equaling, or the derivative equaling 0. When it's undefined is when you have a really sharp change in the graph. Piecewise functions generally have some pretty sharp changes in the graph, or could be like an absolute value function or something like that. But that's when you're going to get the derivative to be undefined, is really coming from a sharp change in the graph. That's when we're going to get critical numbers that are said to be undefined. Relative minimums and maximums. Relative maximum, think about that as a peak or a hump in the graph. Relative minimum is a valley or a dip in the graph. So when you have that information in mind, you can start to make determinations about how things match up. Okay, so you can make some determinations on how things match up. So here's what we're going to do today. What I'm going to do is I am going to, if you looked on the calendar, you maybe even got into I got to close a couple of things out here. If you looked on the calendar, you looked in this thing, you saw, hopefully, if you did this already, if you didn't, that's okay. It wasn't, you didn't have to. But if you go to Tuesday, if you go to this folder, it's a Desmos card sort activity, and I'm going to have you do it in groups. So I'm going to put you in groups, and then there's 20 people in here, probably put you in 5 groups of 4. And the intent is for you to work together on this as a group. So you have to do your own work, but if somebody is falling behind, you got to work together. Now, when you get into this, just so you know, when you click on this link for today, it's a little misleading in the Schoology thing, because it kind of shows up and it's this fancy thing right here, and it even says you can sign in with Google right here. That's not where the link is. The link is actually over here. Okay, the link is actually over here. And I'll actually drop the link in the chat, because what I'm looking for is we are going to be doing, I got to move this out of my way. What I'm looking for is you to get into here, and then I'm going to put you in breakout rooms. So let me show you. It looks like some people are in there, and I paused it, so you can't get past that thing anyway. If you need the link, I will throw the link in the chat, and then you won't have to navigate it through Schoology. You can just navigate it right on here. So you can use the chat to grab it, and that would be fine too. Now, when you're in these groups, when you're in these breakout rooms that I'm going to randomly assign, your job is to do what's being asked of you in here, and make sure everybody you check your work. There's a way to check your work, and it'll be important for you to check your work, and then make sure everybody gets it right. Make sure everybody says they're right, because it's your job to kind of help them along, and it'll be really important for you to have a good basis. If you can explain it to somebody, you really have a really solid understanding of it. And so work together. If you guys have questions, then you need to, there's a way to raise your hand or ask a question in the breakout rooms. And once you do that, then I can join your breakout room. But I'll be monitoring you on the outside here to do it. So I'm going to assign these automatically. Does everybody understand what I'm asking? You guys good? Okay. And this is intended to give you a little bit different kind of activity than the isolation of a Delta Math assignment. I did this with 7th hour yesterday. So here you go. Nick, are you assigned to one? There you go. Open the sharing for everybody.
Straight up.
The activity is paused, Allquest.
What's up?
The activity is paused. We can't start.
Oh, it sure is. Dang it. It's unpaused.
There we go.
Okay.
I think I'd be able to take care of like more than one thing at a time. Sorry. Is that the only question you had?
Yeah.
Yeah.
I thought it was going to be more interesting than that, but oh well, whatever. I'm going to leave the breakout room.
Okay.
Okay. So can I increase time? All right, now I'm just monitoring what the students are doing in the breakout rooms to see how they're going. And looks like there's 248 left, so I'll have to extend that. I gotta fix that on my main thing to see if I can have unlimited time and monitor it a little more like that. All right, so it looks like a couple people are starting it. Right now, I could share this so you can see how people are doing, but I think I'll leave it. Let me go to Andrea's and see what's going on with this. Yeah, I need to go into that room and kind of help them out. So let me go into that breakout room. Before I do that, let me check and see how some other people in that room are doing. Let's see. I think I'll leave it until they pass. Let's see what JC is doing. Yeah, that's looking better. That's how you're gonna have to teach them. Tell them how to collapse these cards. So I'll cast a message. Once you have made a match, if you want to clean up your screen, you can by using the see if anybody's got it at this point. Yeah. Do you guys have a question? How y'all doing? Are you talking to each other? No, you need to talk to each other. I'm watching you and I'm like, these guys are just, I know these guys are not talking to each other, because if they were, they would not be making the same kinds of mistakes. And so here's what I want you to look at, okay? So I'm going to share my screen. And specifically, and you guys can share your screen with each other too. So if I look at Andy's here, when you look at some of these cards and you have them together, there's some things that are going on that aren't making a lot of sense when I look at these. So what I'm going to do is I'm going to pull apart these two, and I'm going to double click on this one and get it bigger. Actually, I'll do one where the window is. I'll do this one. Now, one of the things when I look at this card, I look at a graph that is increasing. This graph is increasing all the way up to right here at x equals 2. And then that graph decreases after it. So we got an increasing graph all the way up to 2, and then a decreasing graph. So what that means is, if you think about that chart, if you think about the chart that you have written down, the derivative that would match it would be a graph that would go from positive values, which would be values above the x-axis, to negative values, which would be values below the x-axis. And that transition would happen when x equals 2. So that's what we need to look for, a graph that goes from positive values to negative values at x equals 2. So take a look at this one right here. Notice on this that this graph is going from positive values, they're above the x-axis, to negative values below the x-axis, and that transition happens exactly at 2. So that's where these two need to be matched up together. These two graphs right here need to be matched up together. If I collapse some of these other ones that you're going to have to open up, I can collapse them by hitting this arrow here, kind of cleans it up. But if you look at it, so notice this one goes from increasing to decreasing at 2. And this graph goes from positive to negative at 2. So that's the kind of match that you want to have. That match right there, where you have two graphs that are essentially talking to each other. Now, these two graphs are talking to each other. This one's saying I'm going from increasing to decreasing. So you have to go from positive to negative at that same x value. So what I'm going to do is I'm going to collapse that one. And I am going to pull apart these other ones. And what I want you guys to do as a group, I want you guys to talk about this with each other. That's why you're in this group. So you can ask each other questions or kind of go over it. You can share your screen after I leave. Does that make sense? Okay, so I'm going to leave you guys, but that's where you need to go, okay? Stop sharing, and I'm going to leave this room. Okay, so talk to each other. Unmute yourself. What's up, Davis? I am going to put you in a breakout room. And what you're going to do is you're going to go into, in the chat, I'm going to Oh, I didn't want to share my screen. I want to go into the chat. And I want you to go to that, and I want you to log in using your school Google account, and you'll go into a matching activity with graphs, and I'm going to put you in a room where they are still working on the first part of it. So I just got to figure out which one that is. I want to put you with, and you're going to want to talk to each other in here. So I'm going to have you, let's see, that is room 5. So I'm going to assign you to room 5, okay? Okay, I want to make sure that you guys are helping each other out. So if somebody has not finished matching the first group, make sure that you talk to each other and that you ask for help. So somebody needs to kind of be the leader and say, hey, has everybody gotten through that first slide and done it correctly by checking it on the second one? And if not, help the other people out by sharing your screen and showing how you got through it, if you've gotten through it, because a couple of people have gotten through that slide in this group, but not everybody has. And so I want the idea is for you guys to talk to each other in this, okay?
All right.
All right.
So
I'm
is
gonna leave the
anybody
room so
still?
you guys can talk.
All right. Is anybody still stuck on the?
Increasing, right? Or am I doing that like opposite?
I was thinking it could be the one that goes from like, it starts up and then it kind of has a relative minimum around 0
This
and then
one?
goes back pot. Yeah. Because that one, oh wait, never mind, that's wrong.
I don't really know, honestly. I'm confused.
Which
I
one are you
think-
looking at?
At this point, we're looking at this one.
Okay. So that looks like a, so I want you to look at the one that is, the one that's on the top, furthest one over on the left.
This one.
Yep. Okay, so talk to me about if you were going to describe that graph to somebody moving from the left to the right, what would you say about it?
It's decreasing.
Correct. And then right at 0, what does it do?
There's a horizontal tangent.
Okay. And then what does it do after that?
It decreases again.
Perfect. Okay, so now if you know it decreases, gets through a horizontal tangent, but then it decreases again, what does the derivative have to be doing? Like what goes with decreasing?
Negative.
Exactly. So you need a graph. So Elizabeth is right. So you need a graph that's negative, gets to, you know, Raquel said it goes to a horizontal tangent, which means that the derivative would be 0, but then it continues negative again. So
Like
which
the one
graph?
far right side in the middle.
Exactly. Yeah. So
Where?
whoever's,
Just, yeah, that one.
no, not that one. The one you
Keep
were
going
just-
right. Far right side. Yeah, that one.
This one.
Yeah, so match that one up. And then let's talk about it. So when you have those two, notice, look at where the change happens. You see how that change happens at that same X value? And you see how the graph that above the top graph is decreasing, has a horizontal tangent, which would mean the derivative would be 0, and then decreases more. So our derivative graph would need to be negative, touch the axis, but then go back negative again. Does that make sense? So keep that, work with that. And there's another one just next to it that you could probably work with and do the same kind of thing. The one that's increasing and then flattening and then increasing again. You probably could get that one too.
This one.
Okay. Yeah. Match
I
that one.
think that goes with the one.
This one.
Yeah, that one.
Yeah.
Perfect. All right. I'm leaving you.
Thank you.
All right. So now we're getting somewhere. Let me.
Hi, our group finished.
Nice job. That's fabulous. What'd you think?
We struggled at first, but once we like established that, I know for like the second one, I was having trouble figuring out which ones were the derivatives and which ones were the original functions. But then Jude pointed out the ones that are shaped like x cubed, their like derivative would be x squared parabolas. So
Yep. The other thing you can kind of look at is you can kind of ask yourself, okay, if one function is increasing, then from a certain point, then the derivative one has to be positive during that same interval.
yeah.
And so you can kind of match up with when they're looking at like, how does it look when they're matched up vertically? You know, you can kind of see them that way as well. So nice job. That's if you finished, if your group finished, you guys can can leave. But nice work. That's fabulous. Good job.
This is a very subjective question, but is it fair to say that the original functions are oftentimes squigglier than the derivatives?
Yeah, I mean that's a pretty good. That's if they're polynomials, that's for sure true, right? I mean, if they're polynomials, because like a x to the 5th curve is more squiggly than the x to the 4th curve. But so kind of, you really kind of want to look at the most significant places on graphs are when you get those humps or valleys in the graph. So relative minimums, relative maximums, and then also when a graph crosses the x-axis, because that describes something as well. That those ideas are really the most important thing, is looking at where are those humps occurring, where are those valleys occurring. So that's the relative minimums or relative maximums. Where are those occurring? And then the other thing is anytime a graph crosses an axis, the x-axis, that should be a focal point as well, because that means something significant is happening to its partner, if that makes sense.
Yeah. All right.
Okay.
Cool. See you on Thursday then.
Nice job, you guys.
Thank you.
Thank you.
All right, so what'd you think?
It was fun, except we realized that when it asks you to like confirm your answers, it says you did great no matter what.
Oh, really?
Yeah, it doesn't actually check, because I thought I got them all right, and then I checked and said great, you did it all right, and then I just went back and checked and messed a few of them around, and it said great, you got them all right again. So
Okay, so that's interesting. I will look into that. You did them all right in the end, because there you have.
we hope so. We
Well, I see
certainly
that-
think we did, but
I think you did. So that's interesting. So that check is written in a code, in a computer code. And I noticed that when I was trying, and I took this code from somebody, but I noticed when I was trying to code earlier this year that it's all a bunch of if-then statements. And if you don't do that right, if you don't get your if-then statements right, they will give you false positives, essentially, like that. And so that's a coding error that I didn't check, because I stole this from some other teacher that must have not coded it exactly right. So I'll have to go in and see what they messed up on and see how I can fix it. No, I probably won't do it for this year, because this activity is over. But I think the key is, so what are the, well, let me ask you guys, what's the key takeaway? Like, what do you look for in graphs?
I would just say like for matching them, like where the function and like is like changing from increasing to decreasing, and then where the derivative is negative or positive.
Exactly, and that's the key thing, right? That's the key thing is you're looking at when do graphs have, when do graphs change from, when does a graph have a relative minimum or a relative maximum? So that valley or that hump in the graph, and then also looking at when graphs change from positive to negative or negative to positive, because that is how you can identify its partner. So that's how you can identify its partner. So good job. Right. All right, I'm going to close all of the breakout rooms and bring everybody back. You got 5 minutes. Okay. So you guys are all back, or most of you are back. Nice job. I noticed, or it was pointed out to me that check system didn't always work, and that was on slide 2 and slide 6. Partly that's because it's a code that's written behind the slide. It's a computer code that's written behind the slide, and so there must be something wrong with that. I noticed that I'd run into that earlier in the year with a different kind of matching thing, and I hadn't looked at this one because I admittedly stole this from another teacher. So I will have to go back and look and see what's wrong with their code, because their code is not right, and it's just a bunch of if-then statements that I got to fix. The key takeaways. Well, let me ask you guys, except for the people that I just talked to, what's the key takeaway? How do you figure out what to match with what? Somebody be brave and unmute yourself.
Whether it goes above or below the x-axis and where it goes.
That's absolutely one of them. Yep. So when above or below the x-axis, so that change from positive to negative, negative to positive, what else?
You can use the local minimum and maximums.
Exactly, that's the other one. You can use the local minimum and local maximum, or relative minimum, relative maximum. So a hump in the graph, a local maximum, a relative maximum, is going to be matched up with a graph that goes from positive to negative. And a local minimum or a relative minimum, a dip in the graph, so a graph that kind of goes down and then back up, has to be matched with a graph that goes from negative values to positive values at that same x value. So that's kind of the keys, and those are the things that you got to take away, and that's why that chart is so important in understanding it. We will do a lot more of this in this unit and throughout the year, because it's a pretty important piece of doing the work. If you didn't finish the assignment, you could finish the assignment. I hope that this was a different kind of thing, that you weren't feeling maybe so in isolation, and I'll try to find more of these. And so if you don't like them, too bad, we're probably going to do more. And if you do like them, yay, we're going to do more. But this is the only assignment you had for today if you got yesterday's done. So, all right. Thanks, fabulous people. Oh, hey, I'll be on the Zoom call for help, and I think I'm going to do it from 8 to 9 tomorrow. So in the morning. That's early, but you're going to have to wipe away the sleepers in your eyes and get up.
Wasn't planning on showing up, but I'm going to be in the pool then, so that's fun.
Hey, that's even better.
Exercise, yeah.
Exercise, yay, swimming.
Mr. Alquist, I just had like a quick question about some of the ones yesterday.
Okay.
Where like it said like where it asked you like where you had to like do like the things on the bottom where like for like f of x and then f prime and you had to show like the value, the feature, and the sign change.
Mm-hmm.
And then just kind of was like confusing to me, and I didn't really understand that stuff.
So we got about 2 minutes left. Actually, class is over like right now. So here's what I want you to do. I want you to go back and look at those because my guess is from the work that we did today, some of that will make more sense now.
Okay.
And if not, then jump on that Zoom call and we'll try to get that straightened out.
Okay. Sounds good. Thank you.
Okay.
I had a quick schedule question because I don't have you next semester. I think I have Miss Johnson. So like I was wondering like could I change that or like how does that work?
So the firm answer is no, schedules can't be changed based on teacher.
Okay, but I have 2 study halls, so I feel like I don't really understand why.
Wait, you have what?
I have like 2 study halls next semester. So like why is it like that?
So now that's a different question. So the answer to your question is you really would have to talk to your teacher about, your study halls and where those are mapped out. I know that other people have said, were you supposed to have 2 study halls?
Yeah, because I'm not taking programming is over and then chemistry's over.
So you maybe need to add a class, or you maybe don't want to add a class.
I have concert choir before school. It's kind of messed up. My schedule's messed up. But.
So what I would do is I teach calculus next semester, 6th and 7th hour, I think is the hours that I teach it, but I'm not positive. Anyway, what you can do is if you have 2 study halls, I know that some people have worked it out that with those 2 study halls, if you have it on both both of them on a synchronous day, that alleviates the schedule a little bit easier for them where they're not doing as many synchronous classes and they've worked it out that way. So I think you probably want to talk to your counselor on that. Now, I don't know if they're going to change for a teacher or not, but
like who's the junior year counselor? Like, I don't really know.
Kelsey Milne, I think. Is it Kelsey Milne or is it? It might be Laura King. It might be Miss King.
Laura King?
Yeah, King, King. I think she, well, let me think. I'm not, look on the school website. I think there's like, one on the school website.
So it's on the school website?
I believe so.
Okay.
I believe so.
Sorry.
No, it's all right. Yeah, I think it's, gosh, I don't know who it is. I'm trying to remember where I've gotten emails from and I can't remember. Okay.
Okay, thank you. Bye.
See ya.